Hello everybody. So last time in a couple of videos we were able to see what recursion is, and we also saw a couple of simple programs written in Python to understand how simple recursion works. Now we'll take a slightly interesting example on recursion again to showcase how to build permutations or anagrams of a single string. What we'll do is in this video we'll see how it is done in the Java programming language, and subsequently in the next video I'll also put how the same algorithm can be written in Python. So let's get started. Let us first create a file called anagram.java, and let us create a class which is public. Alright, now let us create a simple function which is going to be doing the permutation of our string. Now, to understand what an anagram is, if you have a set of characters A, B, C, then the set of anagrams will be ABC, ACB, BAC, BCA, CAB, CBA. So it's usually the number of permutations will be the factorial of the number of characters in a particular string. So here there are 3 characters, so there will be 3 factorial or 6 different permutations or anagrams as we call it, which will be available for this particular string. Now let's try to see how this can be written. Right? Now let's create a function or a method called public void permute. Now let's not think about what the parameters for this particular function is going to be. We'll slowly come to it. Now what we need to do is we need to take an input as the entire string ABC in this case, and we need some way in which we should be able to find out how many of these strings are actually going to be used. If you're going to be using something like a for loop, the general way in which you will be doing it is for int I equal to 0, I less than say you get a string str is equal to ABC. If you know the length of the string, then you will say less than str dot len I plus plus, and then what you will do is you will start getting character by character and try to append one new string. In this case, we can also start using a string buffer, which will now contain the newly created set of anagrams or permutations. But the problem with using a for loop for solving this problem is you should know the length of the string for you to do this. If you do not know the length of the string, or if the string is going to be of different sizes, then a for loop or a while loop will no longer be helpful for you. You will definitely have to go back to recursion. Now, say for example, you're doing it for 3 characters, a string of length 3 characters. So you know that you'll have to put 3 for loops one after the other. But what if the string is of size 4, 5, 6, or for the matter n? Then you will not be able to create that many number of for loops for you to do this. And which is where we will have to start using a recursive algorithm for doing it. Right? Now with this example, we were able to see, even with this for loop as an example, we were able to see that we need 2 things for us to do a string permutation. One is the whole string itself, and the second is the string that is getting built, the anagrams that are getting built, right? So you definitely need 2 parameters to be passed to this function. Now let me erase this, and now let us now pass the parameters. So one parameter is going to be string, maybe the anagram which is going to be created, and the next one is we'll call it remaining characters that are to be used for creating this particular anagram. Right? Now let's get started. Now what we need to do is like we saw in the previous recursive examples, once we start getting a exit condition, we need to print something and then we need to get out, or we need to put the values that we computed into some kind of a list or some container, some kind of collection, and then get out of the function. Now we'll come to that slightly later. Now what we will first do is we need to figure out how we are going to create this new string. In our case, the str is going to be the anagram which is going to be created, or the permutation which is going to be created, each permutation which is going to be created, and we are going to be printing it. So first thing we need to do is to convert this remaining items, assuming that we have the remaining items available to us to be used to create the string. We have the string of size 0, the anagram of size 0. So we need to convert all the items which are there in remaining into a character array. So let us do that first. So we'll create character array of, maybe we'll call it char array equal to remaining dot to char array. We all know that there is a function called toChar array which converts a string object into a character array, right? Once we do that, what we need to do is we need to iterate through. We definitely need a for loop, but not the way we just saw in the beginning. We are not going to be iterating for finding each and every single character. We'll be using recursion for doing that. But for initially, we need to have a for loop to iterate through the characters that are actually there in that, because that is going to be the building blocks for anagram. So what we'll do is for character C in char array, what we need to do is we need to create a new anagram item object. Let me start using string buffer. I can use string builder as well. I'll prefer to use string buffer in this case. SB anagram. This is a potential anagram, right? Equal to new string buffer of str, because this is what I'm actually getting right now. What I need to do is, assuming that str is already having some values, it might be empty in the beginning. What I'll do is I'll want to get that, and I'll want to append the character which is already gotten from here, right? Now, what do I need to do? Now that I've taken one character from remaining, I need to update the remaining items saying that one character has been removed from it. So I'll say string of SB remaining equal to new string of remaining. Now this is going to be slightly complicated. Now I need to delete the character, but for me to delete the character in a particular string buffer, I need to know which index it is in. Delete character at, I need to know the index. So what I'll do is I'll again use remaining dot index of C. Let me make it into different lines. Yeah, let me make it like this. So by writing into this fashion, what we are doing is, first we took the character from remaining and added it to the existing anagram that we are actually forming, which is there in str, appended that character to the existing string, then went and deleted that particular string, deleted that character from the remaining set of characters which is there in remaining, right? Now what we need to do is, instead of using the for loop again to go through it, we'll again ask permute to do this job again. This is the recursive part of it, where we are going to be using the same function to do the next step for me, right? So this time I am being passing SB anagram dot to string and SB remaining to string. Now what are we doing? We are again sending the newly created strings with the reduced items from remaining and added items to str, the anagram, back to be computed again, right? So this goes on and on and on till we reach a point where the number of items in remaining is empty. So remaining the toChar array will become empty. So that's our exit condition. So what we need to do, if remaining dot, I can use remaining dot length equal to 0, or I can use the word remaining dot is empty. If it becomes empty, then that's my exit condition. System dot out dot println. I'm going to print it out. What am I going to print out? It means that all the items in remaining have gone into str. So which means str is now filled. So I'll print str. Right? You don't need to put an else because by default, if this condition is false, it will automatically go here. So that cut till then. Now let's quickly write the main method for this. Public static void main. Here what we'll do is we'll just say new anagram object dot permute. I'll initially give an empty string because this is what we need to pass as input, and here I'll give ABC, right? Let's make this static. There's a better way in which this can be done, wherein you don't have to give the values, the first value which is actually getting generated. What you can do is you can make this private, the existing method private, and instead create another public method void with the same name, but this takes only one input. And this internally goes and calls your private method. Both are exactly the same. It's just how you want to present it. So if you do not want to expose your end program to the nitty-gritties of how you have implemented, this is a very useful method to follow, right? Now let's run this. So it has given me 1, 2, 3, 4, 5, 6 different anagrams. Let me try it with something slightly different. What if I say ABCD? Sorry, ABCD. Oh, we didn't save this. Let us save this. Let's compile this. So this time it's computed all the possible combinations of letters to form these words, which will be 4 factorial in number, right? Now let's try to make this slightly more complicated. It's not complicated, it's more practical, wherein it doesn't make sense for us to have words which only have unique set of characters. So what if we have characters which repeat? Say I have ABB, then what happens? You will have similar letters coming, similar words which are getting formed. ABB is coming twice, BAB is coming twice, BBA is coming twice. If we want to make sure that we have only unique words or anagrams returned, what we can do is we can extend this particular implementation to start, instead of printing it here, we can actually ask it to return, put it into a set. As you all know, a set is a data structure which contains only unique values. So we can use a set to do this particular operation. Let us quickly see how we can actually enhance our existing program to do this. First of all, for us to have a set and for us to start collecting the anagrams, we need to start passing that set also as an input to this particular function called permute. Now how do we do that? We will add one parameter towards the end, which actually says set will contain only of type string. We call it final list. All right. So you'll have to add an import to set. So what we'll do is import Java set. Right. Let me save this. So set is now used. So what we'll do is, instead of putting a system.out.println, we'll comment it out and say final list dot add str. So we've added the, instead of printing it out, we've added it to the set. But of course we need to start sending the set information here as well. So what we need to do is we need to say final list is again being sent back here. So just take a look. What we're doing is we are building this final list as it is. Initially the final list will be empty, and as and when this loop keeps on running, the recursive calls keep on happening, final list will keep on getting added, and finally we'll be able to get it. So we are sending the final list as it is. We're just passing the list as it is so that it gets accumulated over the period of the entire program's execution. Then what else do we need to do? Then first of all, we need to return this particular final list, right? So instead of void, what we can say is I will want to return a set type string, which contains strings. So which means now I also have to return find list. Right. So far so good. Now what do we need to do? We need to call the private function called permute from the public function, from the public method. So what we need to do is we need to create a set here for it to be passed. So set of string, we'll call it final list again here as well. Doesn't really matter. Equal to new. Since set is an abstract class, we need to create a concrete class of that. We'll use HashSet. Then we'll pass the empty HashSet to this function. Then what do we do? Now since we are calling it from the main method, it goes here, it permutes. Let us now start printing the values here. By the time we finish this, we will be having final list which will be fully populated with all my anagrams. Actually, we can still keep it as void. Instead of returning something, we can still keep it as void, because we are anyway passing it by reference in Java here, so we don't have to return anything back. Delete. And then now we'll finally print it for string s in final list system.out.println s. Right. Now why have we done this? We have done this because we wanted to have only unique values to be retained, unique anagrams to be retained finally in our print. So which means that because of using a set, it's going to only populate the unique values. Now let's try this out and see what happens. Let's compile this. Now see, all the duplicate values have been removed. So we had two ABBs, two BBAs, two BABs earlier. Now we have only one of each, because the set by default has made sure that only unique values has gone in, and it is only printed out only those values. Right. Now in a follow-up video, I'll show the exact same implementation in the Python programming language. You can check that particular card on top to take you to that particular implementation.